Can you all hear me? Good morning, everybody, and welcome to the AI in Ag conference. This is the fourth conference, and I see a lot of new faces and a lot of old faces. Happy that you're all here. My name is Tanas Gentimis, and I'm coordinating the pre-conference workshop. You probably got emails with registration, but even if you're not registered, stick around. The first workshop that we're going to talk about is called ExtensionBot, and it's Bridging AI in Agriculture for Enhanced Outreach. We have Debbie Brown from Thea AI and David Warren, the Extension Foundation, and they're going to kick it off. We have two more workshops after that. All of them are in this room, so stick around to find out more. David, Thea, the floor is yours.
Good morning, everyone. So I'm with the Extension Foundation. I'm an AI program leader at the Extension Foundation, and I also happen to work for Oklahoma State University, so kind of split job where I'm Senior Director of Digital Strategy in the Division of Ag. And also, just to briefly introduce my colleague here, Deb Brown. We've been working together for about 5 years. She's actually works for our, at the Extension Foundation as a technology provider for AI called Thea AI, and she's Director of Learning and Engineering. Okay, so yeah, she'll explain more about that when she comes up. So I'm going to start off. First, we're going to hit two topics. We don't have a ton of time, so we're going to move pretty fast. The slides will be available to everybody for download, so you can read them at your leisure. And also, feel free to reach out to me. I've got my contact info in this presentation as well at the end. Looking forward to hearing from everybody. So first of all, I'm going to talk about our chat bot that we built together with Thea over the past few years. And then Deb's going to go into really, before you get to a chat bot, what you need to do, which is get all your information organized and digitized and usable by AI, because a chatbot by itself doesn't do much, right? It all sits on top of your corpus of knowledge that you have. So first, one little thing as we go through here, see if you can pick out which images are not made by AI. So guesses on this one was made with AI. This was with Gemini. And yeah, I know. I'm just showing that image again so that people can take a look at it. All right, here we go. Okay, so just a little about the Extension Foundation. If you're not familiar with the foundation, we're a nonprofit. We were created by extension administrators and directors about 20 years ago to sort of be a force to bring together all the extension services across the country, as well as a bridge to federal agencies and other potential partners, NGOs, for working on various initiatives and tasks. We do a ton of professional development, thousands and thousands of hours every year for extension folks. So we essentially, almost everybody that works in the Extension Foundation has been in extension. So we are sort of extension, supporting extension or extension people, helping drive extension forward to create greater impact. If you want to know more about us, check out extension.org. So when we talk about AI, so this is, we really have 5 initiatives we're working on at the Extension Foundation. This piece we're going to talk about here is really 2 of those, which is one, the data side of getting your data ready, getting data collected, and we're actually building a repository of extension information. Right now we're partnering with about 35 universities or extension services so far that have agreed to put content, to give us the content, and we either go out and grab it by scraping it, or they create an endpoint and we go get it off the endpoint. First part we're talking about here will be the AI tools, and one of those tools we've created is ExtensionBot. I won't go into those others too much other than the engagement and education about AI. I will just put a plug in that I'll be at the Auburn AI and Ag conference in about 3-4 weeks. If anybody's going there, I'll see you there. I'll also be at the NETSI conference. If anybody has ever been to a National Extension Technology Conference, I know NETSI is out here somewhere. We were together there last year. It's at Iowa State this year. It's a great conference. If you want to check it out, it's NETSI. Just look up NETC Conference 2025 and you'll find it. Last year, the Extension Foundation, we chaired and hosted a AI track. We're doing something similar this year. It's not an actual AI track, but we're sort of supporting a bunch of AI content there. I'll also mention, sort of from a collaborations perspective,
We are one of the founding members of what's now called AI AgriBench that was just announced a couple of weeks ago, being organized out of particularly the University of Illinois Urbana-Champaign, the Center for Digital Agriculture there. The founding members are University of Illinois, Bayer Crop Science, Kissin AI, and Extension Foundation. There's some other members that will be announced soon. We're essentially collaborating to create tools to measure the abilities of ag-oriented AI and to set some benchmarks so you know what's good and what's not. Okay, now and I apologize for moving quickly, but we only have 40 minutes and we've already burned about 10 of that. So now talk about ExtensionBot. This is a front end, the sort of default front end for our bot. All this is configurable. The way we built this thing is that we have a central service, and then we have essentially some code, a little bit of lightweight code that can be dropped onto any website. It also could potentially be embedded in apps. It could be in Facebook Messenger. It could be in many different things. And when we work with an extension service, they deploy that front end wherever they want, and it calls the central service. We have some localization logic that applies in there, and it pulls back answers and links to resources. So that's sort of the very simple version. I'll go into that more here in a minute. If you want to check it out, one easy way is to go to my website, or website that my team manages, extension.okstate.edu on my OSU side of life. And on the bottom right-hand corner, there's a little pop-up widget that will be like this little guy right here. And you can click on that, and you can interact with the Oklahoma localized version of ExtensionBot. You can also just Google ExtensionBot, and probably about the third or fourth link down the page will be the version that's on extension.org, which is not a localized version. It sort of treats all content equally. So it's sort of a national version thereof. Okay, a couple of quick points about before we get into anything technical. The reasons we built this thing. So one, we see a great opportunity in AI to augment extension educators. We know that extension funding has not been going up, and we know the workload's very high, there's a lot of burnout, and there's way more people we could reach than we're able to reach now. So one way to do that, and one way that people expect, is to offer more and better digital tools. And more. So that's what we're trying to do here with ExtensionBot, is to help educators get their own answers, because not everybody can be an expert in everything, and that can be available on their phone right now. We also do answer questions from the public. And then our third use case, which is a little more difficult, is supporting ag producers, which we already do, but really for text-based questions. The more difficult ones are the determinative sort of questions of, like, how much of this pesticide should I apply per acre for this certain crop, right? Much harder question. You got to actually calculate real numbers, and you got to get a lot of background information before you answer it. That's the sort of thing we're just starting to work on. So there's a lot of existing capabilities out there, though, that we can build off of. Many extension services, like probably Mississippi State, like many others, have these so-called calculators out there, spreadsheets, that have a lot of this logic already built. So we're looking to essentially partner with various extension services and utilize some of these existing tools that have a ton of research into them to essentially suck them into AI and build on top of that. So that's something I'll mention a little bit here further on, too. Okay, so I'm kind of move quickly. So one of the key points of why extension services should implement ExtensionBot, if they haven't, or they should do something with AI now, is that extension services need to gain experience implementing and scaling AI technologies, because if not, they're going to fall behind, right? There are some out there that have gone out and tried their own things. A virtue of working with us is that we're a partnership. The Extension Foundation has partnerships, and actually it has a membership model, and most extension services, I think about almost 80 extension services, are members of the Extension Foundation and pay dues every year. So we have these existing relationships and partnerships, and we go and we work with each extension service. We don't just go grab their content, we ask them. We say which content is good, which content is not, because quite often we get the answer like, well, our content's not well organized, our content's all over the place. So they help us go find it, and they also say, don't index this over here because this is old, right? That sort of thing. So by working and partnering with extension services, we get the good stuff. So a lot of other benefits, but I'll move past those. All right, so now we get into some somewhat technical stuff, and I'll add a caveat here.
I'm not really an AI developer. I'm a sort of program manager is my background. Is sort of in the tech world. I'm a program manager and product manager is my background, which means I'm pretty technical. And I used to write code many years ago, but not recently. So I'll explain this. It's kind of washed out here, but this is sort of an architecture diagram of how ExtensionBot is set up. And I'm going to wander around here a bit because I got a point. All right, so, well, as I mentioned right here, so I'll start to the front end. So it's a front end that we offer to extension services if they want to embed it on any website or any application to call essentially the centralized function. So a user might come to that, say on the Oklahoma State Extension site, as I mentioned already, and ask a question. It then hits, we have then a series of models. So there's not one model. We're using Llama 3.1 right now, but we have, I think, 3, or is it 4? 3, at least 3. Like this pre-processing step, it hits that, and the model decides whether this particular query needs to go through the RAG loop. I don't know if who else, I think just about everybody here should be familiar with RAG, Retrieval Augmented Generation. So the pre-processing looks at the question coming in saying, do I need to send this through this processing to go get resources? And resources might be fact sheets, for example. So is this a topical question about, can I graze cows and goats together, for example? And it would say, yes, I need to go then through and go find resources for that and need to expand this query. Or is it a question such as, what is the phone number for the Logan County Extension Office? And that, it doesn't need to go through RAG. It knows that it can just send it to the core model, get an answer, and spit it back out, right? So it then feeds it to what is something unique to the models we've been working with Thea is this expansion layer. Expansion layer does several things. There's one model there currently. There could be many models there. It's a way to specialize. Is this second sort of circle? So, for example, the determinative type problems that I mentioned to be able to calculate, let's say, pesticide application rates. It's pretty complicated. One way we're thinking about solving that is to actually create dedicated models. But the expansion layer does more than that. It actually takes the original query and expands it to essentially improve the quality of the prompt. As well as allowing us to do specialization if we want. It then feeds into another model, the embedding model, which then basically goes and grabs relevant resources out of the vector database. We use Qdrint, which is an open source vector database. I don't know if everybody's familiar with vectorization. So vectorization is a way to essentially take all these concepts that we have, let's think about all the concepts that exist within the space of extension, which might be, I don't know, beef cattle nutrition, but it's probably a lot narrower than that, right? But you pick any particular little concept, and then it turns that into a vector space, which is essentially a big graph, right? And assigns it a number, right? These concepts get changed into a number, and then it calculates a distance from one thing to another to discover if this is how related one thing is to another, right? So that's what the vector database does. So essentially, this system is going through there. The prompt hits the embedding model. It then grabs a bunch of related resources. Then it hits re-ranking, which among other things mainly is our localization logic. We have an ability for every state to decide how much they want to weight responses from other states or other extension services versus their own. So, for example, you can say, I only want to see content from, in this case, Mississippi State, if you're in Mississippi, and we could restrict it just to that. Or you want to see everybody's, and have it equally weighted. Most people do a slight weighting bias towards their own content. And that's what the re-ranking does, essentially is applying that localization. Then it hits post-processing, which I'll skip by for now. And then finally, it's hitting the core model, which again is Llama 3.1 currently. It'll probably be something else soon. Last year we upgraded our models, I think, 3 times. And that's where the narrative answer is created. So that whole RAG process resulted in an improved queries, or an improved, prompt, together with a set of documents or pieces of documents, chunks. If you ever heard the term chunking, chunking is what goes on in the background, sort of to break those documents up into related, relevant pieces. So it's bringing in a whole bunch of chunks as well as an improved prompt and links to a bunch of resources that then hit the core model, which then writes an answer, right? That narrative response, which then gets pushed out to that front end. So that's the high-speed version of how ExtensionBot sort of functions. And lastly, I'll mention also that we log everything. So every interaction, both what people ask, what ExtensionBot says, and what links it provides, and other stuff is logged and available on a dashboard, and any participating university can access all those interactions for their university. Just to mention real quickly our front ends, we have right now 3 different front ends, one a full page with, like you might get at ChatGPT. We have the little widget that's showing up down here in the corner that you can put on any web page. And then if anyone's familiar with Ask Extension, it used to be called Ask an Expert. It's something that the Extension that has been around, the Extension Foundation has had for about 12 or 13 years, which is sort of a human-powered search engine where people come to that and ask questions, and it gets routed out to extension experts and then published to a website. That's actually sort of the genesis of this whole project about 5 years ago. We looked at that, and there was roughly 400,000 or 500,000 questions and answers from that, which is a great data set for training if you know AI. So that was sort of our thought, like, well, not only do we have this idea for a bot, we have a great starting data set. And so that's really how we started training it. Really, after you cleaned it, about 300,000 question answer pairs. Okay, I'm coming to the end of my part. So a key thing about ExtensionBot versus other bots that are out there, this is something that's designed by Extension people for Extension to use. We have content that's from Extension services, as well as some USDA content, right? But it's really stuff that's from Extension. We work together with the universities closely. We have a strong commitment to localization, and of course we're a nonprofit. We're also funded by dues from all the participating extension services, of which most all are participants. Okay, so quickly, a couple more things we're doing is we actually have a back-end data infrastructure that's being developed right now. Should be available in about 6 or 8 weeks, we hope. I'm optimistic that soon that is going to automate our data gathering capability, so we make it much easier for extension services to participate. Because one of the big issues in participating and using a chatbot is getting your data ready, right? And there's, like, I can just think of one extension service we've been working with for about 8 months. And the issue is they can't, to get resources, to get most of their content's in PDFs, to get all that together into one spot and decide what is current and what is not. What do they really want out there in a AI, and what do they don't want? That is what's taken some time, right? So if your extension service hasn't really done a effort to clean up their public content in a while, it's probably time. It's way past time. And certainly if you want to take part in AI, whether with us or anybody else. We also are doing a number of other things. We're getting ready to start working on image recognition so people can upload a picture and say a picture of a plant or a picture of an insect or something and say, what is this? And we can tell them. And then more complicated, hopefully we might even be able to say, take a picture of something and say, oh, that's a certain fungus or disease or something, right? That's a little bit farther down the road. And also already mentioned these determinative calculators. That's something we're starting to dig into now. So lastly for me is we have a lot of data already. We've got, in the last 3 months, I think we've got probably 60,000 conversations with, since the first of the year, with people and ExtensionBot as data sets. We also have content and data from about 35 extension services, as well as a little bit of USDA content, and all sorted together in one spot. And it seems like this might be useful for analysis and maybe even research. So if there's anybody here interested in digging into that, reach out to me, David Warren at extension.org, and we can chat. We might be able to work together on that. So for the data side of sort of now the pre-chatbot, I'm going to hand it over to Deb.
So I wanted to take this opportunity to kind of emphasize something that we've been seeing across all the institutions that we've been partnering with, and even within my company with other contracts or other customers like the Department of Defense. All the institutions that are preparing to take advantage of AI are having to struggle with whatever structure or format their legacy knowledge documents are in, and get them transformed into something that's both human and machine consumable. And that's especially critical. I'm so sorry. Okay, I'm so sorry. I'm not used to the mic. I'm just an engineer. So anyway, we want to focus on trying to get this message across, that it's really important for your organizations to start taking these steps if you have not already done so. And as David mentioned, the Extension Foundation has contracted another company to try to automate that process, that pipeline that's going to be feeding into ExtensionBot. My company's been involved in building out that AI architecture. And one of the focuses for today's discussion in the workshop is our document preprocessing pipeline and establishing the RAG system that David mentioned earlier, the Retrieval Augmented Generation. It is LLM enhanced, the chatbot, and we do have an architecture that allows us to swap out the models, and we also have an automated model evaluation backend that we take advantage of. But you can't do any of this until your data is consumable. And you also need to be able to maintain it. Once your institution has gone through the process of transforming your data, it's best to start maintaining it in that already digitized structure. So what we have enabled to begin with our partners is we first established an ExtensionBot JSON data standard. We needed to have a common structure for those organizations that are using a content management system. They can just write an export out of their content management system and publish the JSON dumps, basically. We refer to those as the dumps, in a URL location, and then we are told when those are updated and we can feed them in, we can parse them in. We also provided a validation tool. I'm not going to bring all these up because y'all can download this, get to the links, you can play with everything yourself. But that validation tool allows the IT sysadmin guys to experiment with their export until they get the JSON to where it doesn't get any errors. We are as he mentioned, we have 35 plus institutions. And if we look at this workflow, talking about this process that we're really focusing on, you have legacy data sources. Some institutions only have it in their website. It's just HTML. You have PDFs, you have Word docs, and what we want is the JSON structure or something XML, RDF, something that's machine parsable. So we go through an ingestion process. We've experimented with a lot of different AI-powered parsing tools. That is rapidly changing because there are new tools made available constantly. You kind of have to track that. But these are tools that we were using a few months ago. We've already changed. Sorry, the diagram's a little old. And then once we get the data transformed, we put it up in a data storage where that is now something that can be consumed by any other tech stack. It's somewhere for your institution to share. The part where we start with pre-processing is where it becomes specific to what ExtensionBot needs to consume it. So from that point forward, it is tech stack specific, but the goal would be for your institution to get your legacy information transformed and maintainable in a consumable format, and then you can from that point forward launch any number of things. Just get it into an intermediate, technically consumable format. We do go through with that pre-processing. There's oftentimes we have to do a little bit of cleaning. If we need to extract metadata about the resources, we take care of that because we do want to retain the ownership, the provenance, the links, our goal with the chatbot responses is we do provide citations, and we redirect the question asker to the original sources, back to the original institutions. We're not trying to pretend like it's our information. We're sending it right back to your institution. If you're already doing model building, you're familiar with the context window limitations or max text size that a model can handle to properly function. So we have to go through this chunking process to break down resources so that they all fit within that max size. And then we vectorize those chunked documents and put them into the embedding model and train the embedding model. And then once we've done that, we go to Qdrant. And we are using Qdrant. There's other products out there. So what we've done for the workshop is we've built a Jupyter notebook that's hosted on Google Colab. And I welcome y'all to, you can hit this link and go to it. But before I actually do that, it's going to take too long. The data set, we limited it to just some southern states, and it still takes too long for y'all to actually go through and train the models and stuff during this limited time. But it's homework, right? This is something for y'all to make take the steps on your own and understand how this RAG implementation works. And we wanted you to have that exercise. So this notebook is only covering this top pre-production processing pipeline to get it into the Qdrant. But I also want to briefly point to the uses afterward. Once you get it into Qdrant, you can do simple retrieval out of Qdrant, the vector search. So when you receive a user query, that query also needs to be changed to a vector representation of the query. And then you can search or put it through the embedding model to then go to the vector-based database and retrieve the best documents that match that particular query. So the simple use case is just to do a query and get documents back. When you have LLM enhancement, the next step is you can do localization like we do. We retain all of the citation metadata. So we can, filter out as we need. We also re-rank the Qdrant database returns kind of a similarity score, so we can make sure only the closest matches are showing, and other things that are based on whatever the configuration is for the implementation can take place. So then that builds a context for the response. And the context is combined with the original user query and sent to the large language model. And then you get a nice narrative, summative response with citations. So, and we think it's important, since we're trying to cite our research, we are retaining all of your research. That's not typically happening in most large language models that are just out there scraping everything at random. We are trying to retain your provenance. So I'm going to quickly pop out and go to the notebook. Oh, sorry. Okay, hold on. I don't want to do that. Let's just rerun this. Sitting here long enough, it logged me out of Google. Okay, looks like I'm going to have to do it. And I really don't want to. I think I misspelled something. I'm going to have my password keepers running. Okay, it worked. All right, so if you were to go to this Google Colab hosted book, you have reduced environment to operate this in, so we are not using the complete ExtensionBot data set, but it's still consuming, it's a little less than 10,000 resources that are in here. This example is demonstrating how to use LangChain and the Facebook AI similarity search to represent a RAG implementation. I wanted to show, all of this. We try to provide the narrative so you shouldn't have to actually go through things. But when you're operating with this, if you're not familiar with it, there are cells that have little play buttons, and these already have embedded code in them. So you just click the play button, and it will run in your computer. It actually does download the data models, or the data set that we've made available. And I think the Extension Foundation is going to allow this to continue to be hosted for y'all's use for a period of time, some weeks, maybe? A month, maybe. So anyway. Let's see. So, and then the other thing that we discuss in here is how we are using metadata. If you do retain the metadata, your AI processing is improved because, for one, you are able to do that filtering that we were talking about. We're using it for localization, but there are other metadata features that you could retain with your resources. So it's completely up to you when you're designing your AI what you think is important to keep in the metadata. We also are able to supply that metadata in a prompt or in a query, so somebody can ask the AI to do something based on a particular filter setting or output value. And then we are able to do some ground truthing on the resources. We can add source and create it at timestamps to make sure they're not outdated. You know, things like that can be set on your AI. So, and then search and indexing. We are currently using, in this example, an open source index or vector index, and a hybrid retrieval system with semantic plus keyword plus filtering. And then you can also take advantage of the metadata by the ability to provide additional auditing of your log files and see how successfully it is retrieving documents the way it's meant to, and if you agree with how well they align with the query. So we do have an example knowledge document in here that you can look at, and I didn't load everything because I don't want y'all to wait. But when you come in here, it's going to let you see. What we've chosen to do is we have a JSON scaffolding where all the metadata is in place with the links and the reference for the resource ID within the system. But then we also are actually saving the content from the resource as Markdown, because the Markdown retains organization in the document. It's easier to parse. You know, we're not trying to keep HTML entities in the content. That just makes things trickier, especially since most of the time we're deploying or rendering in HTML. So we are using a combination of JSON and Markdown to store the data or represent the data. Let's see. So, and then the book is going to go through the details of what embedding means. And I know we have a lot of AI specialists in here, so I'm assuming a lot of you already know this. But it does explain that when a concept or a word is embedded, it is actually translated into a vector of numbers. And that is a semantic numerical representation of the meaning of the word. So then it could take the word vector for cat and see the word vector for kitten, and the numbers in the different columns in the vector will have a lot of close matches, but some distinctive differences just based on maybe the age of the animal. So that's how the embedding models can understand text. You can do similar things with images and stuff like that now that we have multimodal models. This example is only doing text. So we do have exercises in here for you to understand embedding models. And then we talk about how you use the vector models. And then we actually are going to build an embedding model. So this is the one that actually takes a very long time to run. You see a prior run in here. And it's just talking about 100% complete on the status. And then we go through the process of chunking. So we establish an embedding model, then we chunk our data set, and we talk about different things that we can use. One thing to point out here is if you use open source models as your base for your localized training, then you also get other tools like chunking tools, re-ranking tools. You know, there's other libraries that are available with the open source model, so it saves you a lot of time. And so we are using chunking algorithms that are available, and we are telling it that it's going to be chunking Markdown because that's what structure our content is in, and basically running a tokenizer. The chunks are measured in tokens, not words, and there's a little bit of a difference there. And I'm still not sure I'm the learning engineer, not the AI engineer. So in any case, the token limitation is the context window. You have a limit of the number of tokens that you can fit or be processed by a model. So we want all of our documents to be within that max token limit. And after the process runs, you see here in this example that we had a couple or some resources that the token ended up extending the limit. What happens when that happens is you just have some of your content that's getting clipped off. So in real life, you would probably go through some iterations and tweak your chunking process to try to make sure it's staying within that. But for this exercise, we just let a few of them get clipped off. And so then we have a visualization so you can see what the different lengths of chunks came out of the tokenization process. And then we have an exploration where you can actually look at the contents of a chunk and you just see the markdown there. And so then we actually put all the steps together. Now that we've explained what embedding model and chunking is, you can go through the process of actually running that pipeline. And we kind of refer to this as our document processing pipeline because most systems automate this. Unless your institution has already gone to the step of transforming everything, that is another step. So in this workbook, we actually are not including the step of parsing all your PDFs and Words and stuff. We're assuming that all the documents have already been transformed. That's actually a critical step. That's, again, why we suggest that institutions go ahead and get their documents into a digitally consumable structure. And so we then rehash the steps for going through the pipeline. You extract the text, you chunk the documents, you vectorize or make the embeddings for the text, and then you build the searchable index or that vector database, and then you train the index with your chunks, and then you add the vectors into the index, and then you save your model so that you can then start using it. So those are the steps to building your RAG implementation. You can actually hit this play, and it has the sample code there, so you can watch that happen. Again, it's going to take too long for what time we have here. And we do have a discussion about understanding the vector index and exactly what it means to have word vectors and relating word vectors between each other. The most useful analogy to kind of explain what we're talking about is, say you have the word index or the vector index for king, and then we want to remove the meaning of the vector index man, and we want to add the meaning of vector index woman. The AI will then know that king minus man plus woman equals queen, because it semantically represents, it's like royal man, take man, royal woman, queen. So that's just a very simple analogy, but that's basically, how the model can make those similarity measurements. Anyway, so then the final step after you've built your RAG and you've saved it, we do go through a process of evaluating the effectiveness of your RAG model. And so what it does is it goes back to your data set and it's extracting queries from your data set, and then it runs those queries against the vector database, and then it shows you the similarity scores of all the resources in the vector database and just saves it into a JSON file. In Google Colab, if you're not familiar, you can see that any output files from a notebook by clicking this files icon, and it would show up had I recently run it. So anyway, let's go back to the PowerPoint. And sorry, I'm jumping all around because I don't usually use the... Yeah, okay, these are going to be quick. Thank you, though, for the reminder. Okay. So why should your institution care about digitizing your knowledge? As we've mentioned before, these AI systems depend on vast amounts of very accurate and well-organized data in order for them to actually function well or give good responses. Unfortunately, AI will give bad responses with no qualms. It thinks it knows everything, so unless you properly structure and get your input data, fed in and fine-tuned your models, it's very difficult to assume that your AI is giving an answer that's trustworthy. It's important that you clean the data. If you've got a lot of extraneous stuff like links to ads, or if it's coming off of HTML, you got navigation stuff, all that stuff is trash. You don't want that in your AI data. You just want the content. We also recommend that you retain the metadata, because that's how you can provide the citations on your AI responses. And then the digital modern formats is going to allow your institution to achieve a lot of goals listed here, but you will provide more accessible and democratized data. It will be preserved and protected for future use. It will enhance your research capabilities, because you've readily made all of your data more usable for all kinds of research activities and analysis. It is going to take a lot less space, and you have the ability to manage these resources more easily, because hopefully you've been able to go through the process that David mentioned of identifying what's still valid, what's good, and you've put it through this process. So now it's all in one place, and you can identify what editors you want to use to maintain the data. It's a very cost-effective and future-proof way for you to retain your institutional knowledge, and it allows you to collaborate and share with other groups. So take a look when you go back home. How digital is your institutional knowledge? Most institutions that we're encountering, even in the government space, it's docs, PDFs, HTML. That's kind of really low down on the ramp of being digitally consumable. You want to get something up high. We also recommend the use of, in addition to JSON, but JSON LD or linked open data. And there are basically a lot of benefits to doing that. So I've got a really brief slide here. Linked open data is an actual standard. It's human readable and machine actionable. By using linked open data, you're able to make resources have relationships to other resources in the metadata layer. So if you start collaborating with other institutions, you can actually tag things with linked open data and have the links to the resources as necessary. Maybe you're merging data streams from multiple inputs, in some remote sensing implementations or things like that. It would allow you to retain original references, and it's in the JSON. So once the JSON is more portable, you can share it, reuse it. That link's always there and retained, and somebody can go back to the original source. AI can use those linked open data relationships to make inferences about relationships of the information in those objects. So it actually makes a powerful statement to allowing your probabilistic AI to make some discoveries for you. So try. And so this is just talking about linked open data. We can skip that. Basically, in summary, there's a lot of advantages of taking the steps to digitize your knowledge. And that was, although there's a lot of exciting AI things happening, this is really your first step. And if you haven't done it yet, you really can't play the games. And we recommend that you take a methodical approach to doing this and plan for your future, and allow things to be much more future-proof and sustained through the future. So I think that's the end here. David, any questions or comments?
Do we have time for any? Do we have time for any questions? Are we done?
Let's thank the speaker.
All right. Thank you.
Let's say I'm running some real-time model, AI model, and that's not an HTML,
Right.
PDF, no, metaphor that we have. So if I want the farmer, like the extension, directly interact with the chatbot with my real-time data coming out, how would that work?
So ExtensionBot does not currently support that. The company that I work for, Thea, has a platform that allows you to integrate data streams into the AI training. And it also supports subject matter experts doing fine tuning on the models, so the models that are supported by your implementation can go through some over time learning from mistakes and feedback that's been collected. This is something, though, that we have discussed. We've talked about the deterministic calculator type tools, but we also have the capability of taking in things like weather feeds or remote sensing feeds. And we've been trying to find a good use case and we would have to get separate funding for that activity, but we would definitely be interested in that. If you want to follow up with us, that would be great. Any others?
My question is, seeing your setup, you use the vectorized database, so then you showed from PDF all the way up to the data space template. If you were looking to collaborate with people, and they were trying to take the PDF and say they use MongoDB and create a document, is that something that's pretty useful? Would that actually
You could look at something like MongoDB as another input source, and that expansion layer, we could have a model trained to know how to go search MongoDB. Yes? Okay. Oh, no. Okay. That's you.
Yeah. So we're just starting, right? So we don't have a real. The strategy is I'm trying to find people interested that want to work on it. And that was sort of my call, and they say, hey, if you're interested in working on these sort of things, my email address is davidwarren@extension.org. I do have some folks particularly in the beef cattle area at Oklahoma State University that are well-known specialists in that area that said they're fully in to help. So to bring their specialized knowledge. So we haven't started anything yet. Last year we actually did a little bit of experiment in this area on a project called BudgetBot, where we took a farm budget, essentially spreadsheet, and there's a whole lot of logic behind it as well that's in Visual Basic, and essentially implemented that partially with an LLM. And Natsia sitting over here is part of that project. She's an economist from Maryland. And we made it to a prototype stage, and then we ended for a variety of reasons. So, but that's sort of leading into, that's our first real experiment in taking some of this determinative logic or capabilities that have been built mostly in spreadsheets that I've seen. And there's a lot of web applications too that I've seen. And so we have a desire, what we're looking for a project essentially, and money. So that's where we're at right now.
Oh.
So in this case, for example, in farm budgets, I know in Oklahoma, for example, they have 3 decades of data for all 77 counties for a variety of commodities. So the data is massive, and it's numerical, right? It's not. It's great big tables of data, and that was ideal for this particular application, but not. Yeah. So, but not for a standard LLM.